Welcome. We're going to go ahead and do Unit 11, Lesson 6, Binomial Probability, Day 1. And before I kind of explain this a little bit, I think it's better if we kind of just illustrate this with a few examples. So we are going to be tossing a standard coin. And if you all know, a standard coin has what options? We can get a heads or tails. And then it says we're going to be rolling a standard six-sided die. So a standard six-sided die, you have an option of getting a 1, a 2, a 3, 4, 5, or a 6. Write the sample space of this experiment using a list of ordered pairs. So I'm going to start with my set. The first one, well, if I have a coin, I can get heads or tails. I'm going to go ahead and say I got a head and the number 1 on the die. Head in the number 2, head in the number 3, head the letter number 4, so on and so forth. I'm sure you can see the pattern. Those are all the possible outcomes I could get if I flipped a head first. Now we move on to the tails. 1, okay, so if you count up here, there are 12 possible outcomes. Determine the probability of getting a head and a number less than 3. Well, there's only one time you can get a head, right? And a number less than 3. Well, what numbers are less than 3? That would be rolling a 1 or a 2. So let's go over to here and let's figure out. Well, here's flipping a heads and rolling a 1, flipping a heads and rolling a 2. Flipping a head, which is we like, but then we get a 3, which is not less than 3, so we can't count that. So for this one, it would be 2 out of 12 possibilities, which reduces to 1/6. Letter C, what are the individual probabilities of getting a head and getting a number less than 3? Well, the probability flipping a head would be 1 out of 2 possible outcomes, right? Because the 2 possible outcomes are getting a heads or getting a tails. I'm only successful if I get a head. A number less than 3, well, this time I know that there are 6 possible outcomes, right? Because I could roll a 1, a 2, a 3, a 4, a 5, or 6, but only 2 of those times I would be successfully getting a number less than 3. How could your answer in Part C be used to calculate your answer in Part B? Well, take a look at the numbers I have. All right, and if you said multiply, you are 100% correct. If we multiply 1/2 times 2/6, we get 2/12, which we know reduces to 1/6. So the fundamental probability principle states that if we want to find the probability that event E will occur, we multiply the individual probability. So let's see. On a 5-question multiple choice test, there are 4 choices per question. What is the probability of getting exactly 3 out of the 5 questions correct? Well, let's see. 1, 2, 3, 4. Here are my 5 questions. Question 1. Question 2, question 3, question 4, question 5. So let's go ahead and take care of those getting exactly 3 correct. Well, the probability of getting correct on a 4-choice question, there's only one correct answer out of 4. 1 out of 4, 1 out of 4. So I got those first 3 questions correct. The next 2 questions I got wrong because the problem asked us to find us only getting 3 out of the 5 questions correct. So that means there are 3 wrong answers out of 4 and 3 wrong answers out of 4. And if you look at the fundamental probability principle, it says multiply these. And if you multiply all of these, you get 9 out of 1,024. So that means 9 times out of 1,024 occurrences will I get 3 out of 5 questions correct. The binomial probability formula looks kind of crazy, but it's not too bad. All the variables in it have meaning. So let's see. Suppose an experiment is run with n trials. So this value right here stands for my trials. If the probability of success for a trial is given by P, so this value of P is my success. Q is failure. And then the probability of exactly our successes is given by this. Okay. So on an island, it rains fairly consistency. If the probability of rain on any given day of the week is 2/3, then find the following. The probability it will rain on exactly 5 out of 7 days of a given week. Well, we got to think about this a little bit because we need P's, we need R's, we need N's. So let's see. I have 7 days in a week, so that's my number of trials, right? And I'm going to use C, and I want to know about 5 days. Okay. Now we got to figure out our p-value. Well, they want to know that it will rain. The probability that it will rain is 2/3. And we are going to go ahead and take that and raise that to the 5th because we're saying it's going to rain 5 out of the 7 days. Well, if it rains 5 out of the 7 days, that means that 2 of the days it's not going to rain. Well, what is the probability that it's not going to rain? 1/3, and I get 1/3 because 2/3 plus 1/3 is 1. So those P and Q values will always add up to 1. So now you're going to put this in your calculator. Cross your fingers. I hope my calculator is going to work. All right. So you're going to go ahead, turn your calculator on. You're going to hit math. You're going to go over to PRB, and we want this one, choice 3, NCR. So it looks like my calculator here has the old operating system, so I'm just going to have to do it slightly different than you might have to do in class. Math, PRB, and that was choice 3, NCR, and I want choice 5, and I'm going to hit enter. So that gives me a value of 21, so now I'm going to multiply that value by 21 divided by 3. Raise it to the 5th, and again, my calculator has the old operating system, so it's kind of annoying, but that's okay. Times. And I get this number. Oh my goodness, look at this answer. And if you notice, what did I do? I made a mistake. Don't make mistakes like this. I put 21 divided by 3. So I'm going to go ahead. I did it on my other calculator, which I like better. I'm going to go back to this. And if you do it correctly, you should get 0.307, whole bunch of other decimals. If you convert that into a fraction value, you get 224 out of 729. So if we were to conduct this experiment 729 times, 224 of those times, it will rain exactly 5 out of 7 days. The probability it will rain on exactly 1 out of the 7 days of a given week. All right, so now we're still talking about 7 days in the week. We still have 7 trials, and this time we only want it to rain 1 day. So the probability of it raining is 2/3, and we only want it to rain 1 day. So the probability of it not raining is 1/3, because remember, 2/3 plus 1/3 is 1. And this time, there's 7 days, it's raining 1 day, so that means there are 6 days where it is not raining. So to save time and not to make any more mistakes, I did this before, 0.00640 ... And if you convert that to a fraction, you're going to get 14 out of 2187. Okay? And again, that was hitting the math button, going over to PRB, and then finding the button that says NCR. Which of the following represents the probability of getting exactly 4 heads when flipping a fair coin 8 times? So how many trials do I have here? Well, I'm doing this experiment 8 times. 8 choose. How many times do I want to be successful? I want to be successful 4 times. If you think about it, the probability of getting ahead when you flip a fair coin, well, there's 2 choices, right? Heads or tails. Heads counts for 1 of them. I want this to happen 4 times. I want to get ahead 4 times. The probability of not being successful, in this case, getting a tail, would be 1 out of 2. And I'm doing this 4 times. And if you notice in all of these examples, the exponents, 4 plus 4 is 8. 1 plus 6 is 7. 5 plus 2 is 7. So your exponents will always total the number of trials, which kind of makes sense if you think about it. So if you put that in your calculator, and again, please be very careful when you're entering things into your calculator, you should get choice 3. 35 out of 128. Michaela has a probability of making any free throw in basketball 80% of the time. If she shoots 6 free throws in a given game, which of the following is closest to the probability that she will make exactly 4 out of 6 free throws? It's like a tongue twister. So in this case, I have 6 trials, right? She's shooting those foul shots 6 times, or not foul shots, free throws. And it's saying has to be successful 4 of those times. Well, she is successful 80% of the time. Well, here's the thing. You can't use a percentage. You have to convert it to a decimal. So that means she is successful 0.80 times. We want this to happen. We want her to be successful 4 times. That means she will be unsuccessful 0.2 times. And if she's successful 4 times, that means she will be unsuccessful 2 times because there are 6 trials. Again, be very careful when you put that in your calculator. And it looks like if we look at our answer choices, they converted their answer back into a percentage. So hopefully when you put that in your calculator, you get choice 4. So I went ahead and put that in my calculator. And again, it's going to look different on your calculator because mine has the old operating system. But I got 0.24576. And it says what is closest. Well, if I convert 0.24576, I would get 24.576%, or about 25%. A good hitter in a professional baseball will get a hit about 1/3 of the times he comes up to bat. What is the probability that a good hitter will get a hit each time if he bats 4 times in a game? Okay, so this is about figuring out what's going on. So, how many trials do I have? Well, they're saying he's going up to bat 4 times. Then they want to know that he will get a hit each time. So how many times is he going to be successful? Well, if he's successful every time, he's going to be successful 4 out of 4 times. He gets a hit 1 out of 3 times. So this time this is going to be raised to the 4th because I want to be successful 4 times. I'm going to be unsuccessful 2 out of 3 times, but I'm raising this to the 0 because I don't want to be unsuccessful. And the neat thing about math is anything raised to the 0 power is 1. So 4 choose 4, 1. This becomes 1 out of 81. So I'm multiplying times 1. So that gives me choice 3. So again, in this lesson, we introduced a few probability formulas. Some of them can be found on your reference sheet. Some of them can't. So it's a good idea just to get a basic understanding of this and just move forward from there. Okay, thanks for tuning in tonight.